Let's review some basic probability. So to get started, suppose you flip a coin twice. What are the possible outcomes? We've got heads and heads, heads and then tails, and then you could have tails and heads, and then tails and tails again. That's your sample space. So the question may come up, what's the probability of getting two heads? Well, the way we write that in probability terms is P to H. Or you can also write it in this way, probability of heads and heads. It's really up to you. So what is that probability? Well, let's find out how many times can we get heads and heads. Just once. And there's a possibility of 4 outcomes that we could get. So this answer just comes out very simply to 1/4. So a little bit harder here. What's the probability of getting tails at least once? So this is asking us, what's the probability can we get any combination of tails in there? Well, that's quite simple too in this example, because we see that we have a tails here, tails there, and since it asks for at least 1 tails or greater than or equal to 1 tails, here we have 2 tails, so that means in this we have 3 out of the 4 possibilities making that happen. So 3/4 would be our answer. So some quick notation here. Probability of A, as we discussed previously, is the probability of event A. So if we have a sample space here, and this is A, that's the probability that A happens. Now, the probability of A union B, that would be an example of we also had an event B. So A union B is the probability of both of these guys happening. Next, we have the intersection, A intersect B. So that's asking, when do they both happen? And that's represented right here in this crossover. Now the challenge comes here, probability of A given B. So given that we know B happened, what's the probability that A happens? I like to look at this one in a different way and say, well, let's read this a little bit backwards. If we know that B happened, now we want to know the probability of A, and previously we already said that probability of A intersect B divided by the probability of B will give us that calculation. Then we can pretty much limit our sample space by saying, okay, so we know that B happened, so let's just look at B. This is our circle of B. And now they want to know what's the probability that A happened given B happened. Well, that's just this area right here that's left over from the intersection, isn't it? So there it is. Now some other notation here, probability of AC, this notation here means complement. So that's going to give us 1 minus the probability of A. You might also see this in other texts as the probability of A with a bar on top. And it's still the same, the probability of 1 minus the probability of A.